Yeah, so hi all. Just testing the recording. Yeah, let's wait for 10 minutes. Let's hope people join and then we can begin the session. Um, Hi, Shiv. Joined and left. Let's wait for 5 more minutes and I'm staying here till 8 p.m. So Let's just hope some people join by 6:15, 6:30. Hi Sharon, I think you have joined the meeting for first time, right? Okay, after that you didn't join. Okay, no problem. Actually, last week I was out for some conference, so I couldn't conduct it on Friday. And they didn't allow me to conduct it on weekends because the slots were not empty, something like that. I asked them to conduct this session on Thursday last week only, but they said they don't allow like on Thursdays as well, so I had to conduct it on Monday. Anyways, how much of the course has been completed? 8th week. Let me share my screen and you just keep up with it. So please stay till the end of the session, okay? Uh, it would be really helpful for me as well because not just this. Since like a lot of people are not there, I will discuss the assignments and then we can like what sort of background do you have? Sorry, mechatronics. Okay, so that we could have a nice conversation about robotics and all if you want. uh, okay, it is a combination of both. Actually, the no. See, the problem is not that. See, you should know. Why you should know? Because in future, while developing something, if some issue comes up with the algorithm, okay, then these things help you out if you know the concepts that yeah, this algorithm is not working. What I can do is I can implement my own algorithm or improve it. Okay, so people working in high level research and development part, they should know it. Yeah, you're saying something. So see, generally this happens. This happens with those people who frequently do not work in ML. They do development stuff, and but the problem with that is, yeah, you tend to forget, and that's why you have to make notes and all, so and keep on revising them. Okay, right, great, no problem. See, like now we all do, like we all have. That is a like general like personal opinion. We all have suffered a lot in some way or another in bachelor's, masters, PhDs. But like we have to move forward. We have to work on ourselves only. Nobody is gonna. I'm a PhD student at IIT Delhi. Okay, CS, you can do. Where are you doing your bachelor's from? Okay, so what is, I don't think so that is a CFTI. Is it a CFTI? Centrally funded? No, your university. Anything in mechatronics, nobody is going to offer. Like, it's very rare. There won't be any courses. Okay. The only institute that has some grasp, and that's a new institute, that is IIT Hyderabad. They do some real work there. Like, recently visited them, that institute. Okay. So what you can do is you can give GATE exam, and once you have given GATE exam, oh, you're in second year only. And then don't worry, just keep then trust the process and follow whatever you are studying. In second year, you cannot study machine learning as whole and just try to remember it all. It's impossible. You are like 18 years of age, 18 or 19 years of age, right? Yeah, that's what. Like, it takes time. You should give some time. It takes time. Okay, so for a second year student, you know a lot. I'm saying, like, don't worry about it. Okay, so that is not an issue. Take some time. Okay, and keep on doing it. Like, if you're not able to do this course, it's not sufficient, go to Andrew NG course. If that's not sufficient, there are like billions of documents and courses present online which can teach you. Okay, and then study some questions of machine learning, try to answer those questions, not these NPTEL questions. These NPTEL questions are very easy. Okay, then try to find the answers of those questions. That's how you will learn it. Try to learn it intuitively. Initially you learn the intuition, then you learn the theory. Okay, it's always like that. See, the problem is this course is not a beginner level course, I would say. Okay, and also it's not a course that is applied machine learning course, whatever you're saying. Okay, and third thing is, say if you want to do stuff in machine learning, it's gonna take time, first of all. Second thing is, I forgot, I was about to say something. Yeah, so like as our teachers, as students, we have all faced that. For some students, I would not say, but for many of the students, maths is a very difficult subject. Difficult because we try to mug up things. Okay, so see, you have to study everything by theory, but initially when you start learning something, you have to know the intuition behind it. That intuition leads to development of theory, and that theory helps a lot later on. Okay, so for every algorithm in machine learning, loss function is there, whatever it is there, first try to learn the intuition, then go for theory, and then go for code. That is a proper process. Okay, code is, you can just give ChatGPT, that eases off your work. But that's not the case. That's not the case with theory. Hmm. It is okay. I would say it is okay, but you should know. You should know what are the parameters in that scikit-learn code. What are the arguments that you have to set? So you should know arguments. For that, you have to know the theory. For that, you have to know the derivations. For that, you have to know the edge cases, case studies, everything. Okay, so lot, yeah, yeah, you should know the working. I mean, it's not like a driving a car. Car is for your convenience. This is for your knowledge enrichment. Okay, so you have a car, you drive the car, you don't want to know how the car is working. It's fine, but this is your like this is going to be your livelihood someday, or that is going to be like the whole uh, you know occupation of yours. So you should know in and out of that. If you just know the wrappers, that's not going to help at all. Okay, so anyways, let's begin the session. I think we have sufficient people. Anybody else wants to give their introductions or any personal doubts they want to ask? Sharon is done. Swaroop, okay. Raviraj, Raviraj, you want to say something? I've seen you in quite sessions, like quite a lot sessions. I don't think so. You usually ask doubts. Like today, people are very less. So you can join and you want to share something. We will start the session. Okay, no problem. Manjula, Manjula, am I audible? Okay, I won't ask anybody else, otherwise people will leave. Anyway, so yeah, let's start the doubt session. Anyways, I'm recording it. So um, till last week, I think we discussed week 8 that ended on 19th. Okay, so we will discuss week 8 of this year, and then we'll also discuss week 9 of previous year, and I'll upload these solutions there also. So please don't leave, just stay on this, okay? If you have any doubts, just let me know. If you don't have doubts, please stay. I would suggest, okay? So these assignments which I discussed, they will help you a lot in solving the assignment. So I don't know why people don't join. I usually solve all their doubts here itself. Okay. So did you have any doubts in week 8? Last week, the last week's assignment. Okay. Anyways, still I'll discuss all the questions. Okay. So why isn't it zooming? People are joining and leaving. Okay. So yeah, week 8 is here. What is the key advantage of using bidirectional RNNs? Okay, so as you all know, bidirectional RNNs are capturing input from both ends. So you have a text, my name is Sahil. So forward RNN captures my, then name, then is, then Sahil. And then backward RNN captures Sahil, name, Sahil is, name, I, in that direction. So in that way, they capture forward and backward essence. Okay. Just a second. So yeah, so access information from both past and future timestamps. So you are going it from present and past, both the things. I'm showing it in from your direction, I think. I don't know if you're getting my mirror image or not. Which of this is true with respect to activation functions? So relu is a linear activation function. No, relu is not a linear because relu is like this. It's a steps linear, then it has a constant. Okay, tan h has range 0 to 1. No, tan h has range somewhere, but yeah, tan h, what is the range of tan h? Range of tan h -1 to 1. Yeah, correct. So your sigmoid, sorry, let me pin it for me and then do this. I need to show my face to NPTEL people, otherwise they won't give me certificate. So yeah, tan h is that relu is and sigmoid are good evening Praveen, 0 to 1, while this function tan h is from -1 to 1. Yeah, activation functions learn nonlinear function features, correct. Complicate, yeah, this is the correct one. Sigmoid has range this one, tan h has range this one, so they are swapped. Okay, so what are the key differences between Xavier initialization and naive initialization in context of neural networks? Okay, so I already discussed in last week. These all initializations maintain variance because they pick what you'd say standard deviation from the same sample. So from a uniform sample or normal distribution, so they maintain variance. But while naive initialization sets weights randomly, so one weight will be 0, other will be -200, the next will be 2000. So that's what Xavier does. It maintains weights between a range, and so it maintains variance. Assume a smooth learning rate decay model. Learning rate this, decay is this, new learning rate. So that will be 0.1 minus 0.01, 0.09 minus 0.01, like that, and we do it for 65 steps. Okay, so no, actually it shouldn't be like that. The decay also decays. Can anyone solve this question for me? Praveen, did you solve this question? Yeah, correct. 1 plus decay, something like that, correct. Yeah, so this will be 0.1 divided by the decay is 0.01 into 65. Am I right? It's 1 plus, okay, we have 1 plus. So it will be 0.060. This is the correct answer here. Let me write the formula here because I don't think so you were able to see my on-screen calculator. So it's 0.1 divided by 1 plus 0.01 into 65. Okay, any doubts till now? Any doubts? Praveen? Okay, great. Okay, you have to perform z-score normalization. This is just summation divided by that formula is there. Like you can solve it. It's a very easy question. No concepts required. Sixth question. Okay. Actually, that should have some code for it. Yeah, that should have some code for it. I mean, it's not. It can be solved, but it will take some time. So they will give the solution to this question. Okay, that's why I don't solve numericals. Actually, I do solve. You know, numericals are interesting, but these are direct numericals. Okay, so mostly they will give the code and you can run the code and solve it. Okay. In week or two, like first five assignments are solutions have been released. In upcoming weeks, the next 6 7 assignments after week 10 assignment is over, you will get solutions, and after that you will get two other solutions. So these will be just codes, and I am not writing code because then people don't understand that code. Like last sessions we conducted, we wrote a lot of code for linear regression, logistic regression, and all. So it uh, wastes time for both of us. Like had I written the code earlier, so it would have saved a lot of time for both of us. But it just I can actually solve it in front of you with using ChatGPT. So I'll show you. Okay. So yeah, let's. Which of the following statements describes benefit of batch normalization? Batch normalization improves, reduces complexity, helps the speed of convergence. Yeah, it helps of speed of convergence. Correct. So let me take screenshot this question. Okay. Let me ask the LLM to solve it. Mr. ChatGPT. Okay. Solve these questions. Is it visible? ChatGPT. Which okay. Anyways, let me share my screen for ChatGPT and add windows. Let me add this window as well. Now it should be visible. Yeah, so the values are 0, 1, 2 for the y is okay. This is given here. So see, what is the value of hidden state at time step? So they apply this thing and you get values, these values. So what is the answer? 0.99, 0.199299, correct. What is the value of total loss? I will share the solution with you, okay? I will share the solution with you. By the way, deadline is over, yeah, deadline is over. I'm not solving, this is 0.2025. The answer is wrong. For question 8. Okay, no, it's not complete. Okay, it's not complete. Still solving. Just wait with me. What is the total loss? Overestimated. What sort of approximation is this? This 5.2 is approximated to, it should have been approximated to 5.6. Anyways, that's how you can compute the loss. I don't know what the answer is correct or not. But the first part was correct. Let's see the derivative. Yeah, for this one answer is correct. Okay. Yeah, so I mean your doubt is solved here. I will share the solution with you. I have to make actually LaTeX of this. So anyways, I'll leave it. So I will share this post here. Praveen, I'll share this with you after some time after the session ends. I'll have to convert it from LaTeX to PDF. Okay. Yeah. So the last and final question is, in context of deep neural networks, how do LSTM RNN differ in terms of handling gradient? LSTMs avoid the problem of vanishing and exploding gradients better than RNNs due to gating mechanisms. We all know that. That is the correct answer. So, any doubts till now? If anyone has any doubts, just let me know. Am I audible? Hello? Hello? Say something, guys. Anybody can unmute themselves and say? Okay. Okay, so yeah, this week, 8 for this week is over. Now let's discuss week 9, last year's week 9. Okay, can you explain third question once again? So actually, I explained last week also. So if you watch the video, you will find it. I gave a very detailed explanation why Xavier maintains variance across layers and how it picks the weights. See, so if I ask you to pick some weights from a random randomly, so what you will pick? You will pick something random, very random. The problem with picking random things is you do not know what should be picked most and what should be picked least. Okay, so these distributions, these normal distributions, which are used by Xavier and Xavier, Hay, Glorot, etc., they have one thing in common. They use some proper distribution. So if I have a distribution, say like this, so this means that some middle values close to zero or close to some given value are very high number. So when we pick a random distribution, we assume all values are equal in number, and we pick and we get lucky. If we get lucky, we will have a very balanced model, but randomly picking, that's the problem. So when we have distributions, so assume there are like 5,000 values for 0.1, 3,000 values for 0.2. So what are the chances of picking 5,000? That is 5 by 8. Sorry, 5 by 8. Yes, 5 by 3. And what are the chances of picking 0.2? That is 3 by 8. Okay. So that's how this Xavier helps, because that gives you some balance between values. You do not pick extreme values because they are very less in number. Okay, so that's how this Xavier helps in maintaining variance across layers. Now since the variance is not exploding, most of the values are between 0.1 and minus 0.1 etc. So it helps a lot. Okay, I hope I answered your question, Raviraj. Cool. Let's go to week 9. Okay, I'm not able to zoom it. Just a second. Which of the following is true with respect to gradient boosting? A weak learner is decision tree. Yeah, gradient boosting has. Have you studied week 9? How many of you have studied week 9? Okay, anybody else who has studied week 9 and wants me to discuss the doubts, etc.? Okay, so anyways, I'll discuss these questions so that yeah, you whenever you solve it, you will find it helpful. So gradient boosting is what is gradient boosting? Do you guys know? So shall I explain it? Let me explain it. I'm very good at explaining things. My iPad should be visible to you, and my presentation is also visible, so I can pin. Okay, so iPad is visible and that is visible, right? Both of the things are visible. I can unpin this. I can just remove this, move it here, and then unpin this. Yeah, that should be fine. If you let me change layout to spotlight, hide tiles without video. Yeah, so this is my screen, this is my iPad screen. You can watch both of them together. Okay, so question is opened here while iPad is opened here. So, can anyone tell me what is gradient boosting if you have studied, or let me explain? Shall I explain or somebody will tell me? So, boosting or gradient boosting algorithms, okay, not studied, no problem. Yeah, I will explain it. So, tap into pen. So boosting algorithms. If you don't understand, just let me know. So assume I have this algorithm here. This is some algorithm A1. Okay. I give it some x, I give it some y, so and train it, and then whenever I pass some x, so this is training, and while testing, whenever I pass x, I get some y dash. Y dash is the prediction made by this model. So problem is y dash can be very far from y. It can have some losses. Okay. So next step, what you do is you compute the loss. So loss is L. L is equal to y dash minus y. Assume this is the loss. Okay. Square something. What you do is now you train another algorithm. A2. Okay. You pass x here. You pass loss here. This loss is passed here. Instead of y, now you pass the loss. So this is how you train. How you train it? You ask the model. Okay. You ask the model to no, actually don't pass L here actually. You pass zeros here, a lot of zeros here, and you pass x here, and you get some loss L1. Okay. So the training part is that you have to train this model such that, I mean, you pass, like currently you are passing y, it gives some y dash, so you train it such that your L1 gets close to 0. Okay. So when L1 gets close to 0, now this means that your loss has reduced to 0. For this given input, your loss has reduced to 0. Everything correct till now? You train this model on your losses and you see if the loss is close to 0. Any doubts till now, or should I explain it again? This is a very basic, I will explain it again, just in case. Okay. So I gave it some, sorry, I think I did some mistake. I'll explain it again and I'll see that like what mistake I did. What is this? There's some x, there's some y. I train this model. This is model 1. It gives me some y dash. Okay, now we compute this loss here. We pass y dash into next model and we get some new y double dash here. And we compute the loss again. Okay, so assume I'm computing the losses. I'll tell what other thing I pass here. Okay, so ultimately this assume this loss is 3.8. So this loss should have been reduced to 2.5 something. Okay, got it? So we pass y dash, y dash here. We get some value y double dash. So this y dash is passed and this L is passed. Sorry, this L is passed here. This L is also passed here, and this y dash also. Shall I write L double dash or L dash something? It gives me another loss value. That loss value should be reduced. Should be reduced to 0. Okay, I give y, I give loss, the loss, and I'm giving the loss along with it, and I give the label equal to 0 or something like that. So if it gets reduced to 0, this means the loss is 0. I mean, you're getting my point. If it doesn't get reduced to 0, we add another model here. We again pass the loss, we again pass this y dash here, and then we again train the model. Okay. So we do it, keep on doing it until we get loss comparatively equal to 0. So you're seeing that we have lot of models in what we call this sequence, this cascade ensemble. So if we take big models, The problem is that it will overfit and it will ultimately make loss equal to 0. We don't want overfitting. So that's why we use small weak models such as decision trees of say layer depth equals to 2 or max to max 3. Got it? Got it? Any doubts? So yeah, I mean this is a general. I'm not telling you technicality. I'm just telling you why we use. So if I assume I use a big model here, then again a big model here, ultimately we'll start to overfit, and it will give you loss equal to 0. But that is like overfitting on training data a lot. So even though we do not want loss double equals to 0 all the time, we try to get it to 0. So that's why we use small models and see how much it can be reduced with small models. Ensemble is the key. Ensemble is always the key. So this is how you do gradient boosting. I mean boosting generally, but gradient boosting is some other thing like ADA boost and all. They have some other concepts. They are derived from computer vision. But this is the general crux of it. Like all the methods follow this type of structure only. So I hope that's clear to you. Any doubts? Any doubts? Any questions? Anybody wants to ask? Yeah, hello? Yes, yes. I will prepare. Yeah, I will prepare that next class because if I start writing the code, it will take a lot of time for me. I will waste this time here. So in next class, I'll discuss it. So next class, I will show how these boosting they work. How what I'm writing. How boosting works in code. I will show you some simple examples, like basic examples of. I will simulate this thing. That is the correct word. I will simulate these operations in Python. Okay, and then you will be able to understand. Getting yeah, I think that's what you want, right? Okay. So I will give two things. I will give Python code of ADA boost and simulation as well, so of boosting and simulation, both the things. So simulation will not be exactly boosting, but it will give you a picture how boosting works. Okay. Praveen, you have some question? Yeah. Completely different. Completely different. Let me explain it. Since you asked it and people here haven't studied it. Okay. This is my data. I will explain bagging now. Okay. Here we are using the same data. Here we are using same data. Yeah, yeah, sure. Mm-hmm. Mm-hmm. Yeah, sort of correct. So here you improve misclassifications by reducing loss. And so let me explain. See, let me explain. So there is bias, there is variance. Okay, variance arrives due to noise in data. Okay, and bias arrives due to models inefficiency to learn. Okay, that should be clear. So see, when you have, see, what are the two definitions? Listen to me, 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 listen to me. Okay, let me explain. Let me explain it. Then I will just say 2-3 lines and then you can say whatever you want. Noise in data. Okay, so where's the error? Where's the whole issue? Whole issue is in data. So what we do here, we perform all operations. We improve data. We basically I'm not highlighting. I'm writing. So we hack the data somehow. We just a second. I'm getting some message here. We somehow hack the data. Okay. In variance, we hack the data, and in bias, we hack the model. So see what did we do? What did we do? This model was insufficient to learn the nuances of data. I added another model. Okay. Then this model was inefficient. Then I added another model. I use the same data. I use the same data. So in bias, in bagging, what we do is, see, assume these are the data points. Okay. These are the data points. So this data point is noisy. 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 Got it? Got it, right? This is clear to you. Like these data points are noisy. These all data points. Okay. Now what I do is I basically split this data in some equal intervals. So this data has been divided in 1, 2, 3, 4 parts. Now what I do is in bagging also we use small models such as weak decision trees. I train one model on this data, I train one model on this data, I train one model on this data, I train one model on this data. Let me remove noise from this part, okay? So as you can see, model 1's output is noisy. It can be wrong, right? Model 2's output should be perfect. Model 3 should be noisy. Model 4 should be perfect. And assume we have another model, model 5 without noise, which is also perfect. Okay. So assume I pass some value x here. X, 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 X. And they all give me some output. Okay. So assume this noisy model gave me 0, this model gave me 1, this model gave me 1, this model gave me 1, this model gave me 0. Okay. So see, since now what I do is how many zeros are there? There are 2 zeros and 3 ones. So what is the majority class? Majority class is 1. We take the output 1. Okay. So what did we do? We split the noisy data in such a manner so that we don't have to worry about that our one model learns noise. Okay. So this is ensemble. We do then basically here majority class, majority voting. Okay. So this gave me an assumption, a thing that that if we split the data in smaller chunks, the noise will also get split in chunks. So some of the chunks may contain noise, some of the chunks will not contain noise. So in that way, some models will perform, some won't perform, and that basically helps a lot. That basically helps a lot because yeah. So anyways, to further improve this, what we do is we add some other classifiers as well. How we copy this data here as it is, we shuffle this data, and then we do again sampling, and then we create some other new models. So in that way, again the noise might get distributed to some smaller places, and we will have some other combinations of data, and we will have some other perfect models. Okay, with some different combination of data. Correct? Am I right? So then you have more perfect models. So that's how this thing works. So you shuffle, you chunk, and again so this is bagging. This is bagging. Got it? Then in random forest, what is the problem? So random forest, they add another thing. What they do is So they say that let's assume I have some models here. Let's not train one model on all the columns. On all the columns. Let's train say this model on these two columns and this model on these two columns for this batch. Okay, and let's train this model on these two columns, and let's train this model on this column and this model on this column for these two batches. Okay, so in this way what you do is you do column sampling. This is known as column sampling. Now if your only one column has noise, say assume this column has noise here, so this model will be noisy, but this model will be good. Okay, so it will give me something relevant to this columns, so this output will be relevant to this column, because we do not want to basically lose this information just because this data is noisy. Got it, Praveen? We do not want to lose this information because this data is noisy, so we basically remove this and train another model here and use this to train another model. So these are all techniques in bagging. Bagging is you don't keep all the eggs in one basket type of thing. Okay, so I think that should be clear for bagging and boosting, the basic difference. Okay, cool. Yeah. Mm-hmm. Yeah. Yeah. Yes. 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 Generally, we keep the number of classifiers, these small classifiers, to odd, so that, and if the number is closely equal, now that means there is some problem. So the number is generally not closely equal. So even if you keep even number of classifiers, you should not have equal classifications, or like two more in this and two less in this. This is not the case. This should never be the case. There should be a stark difference between them. It's not like this zeros are in six classes, six models, and one is in four models. It should not be like that. It should be at least 70-30 or more than that. Okay, so this is the whole concept of bagging. So next thing, let's go to the next question. Any doubt till now? So another 13% was joining. Let me just add the attendance here. Okay, actually I have to keep a head count. Okay, so yeah, let's go to the next question. Regression trees allows the input variable to be mixture of continuous and categorical. Correct. Terminal nodes contain predicted output values. Terminal nodes should contain predicted output values. Just a second. The screen is not visible. Oh, sorry. Screen is not visible, not just questions. Now iPad is visible or not? Okay, anyways, screen is visible, right? So terminal nodes generally contain the output value because you keep on splitting, and ultimately you add and aggregate over there. So root node does not hold the prediction values. Terminal nodes contain the output value. So this is the incorrect one. These all are correct. Variant of decision tree is designed to approximate real valued functions. Correct. So it seems like these are the two options which should be confused. So this is the wrong one. That is the correct one. Weak learners aggregate typically see what is the correct word bagging. Weak learners aggregated typically outperform a single learner over entire data set and has less overfit. See, we are now less overfitting. We have the variance distributed and we are now less overfitting because the variance was high, noise was there, and since that's why we hacked the data and we created split. Reduces variance in high variance data set, correct. It reduces variance by splitting the data set. Parallel processing for both training and evaluation, correct. Parallel processing. How is it parallel processing? Because you input all data and it parallelly goes in all the models and then performs all the operations. Okay, last one, which is true about k-means algorithm. It's a unsupervised. It is not supervised. It's unsupervised. It's a parametric learning. No, it is not parametric learning because there are no parameters there to learn that. That just learns the centroid, I think. Yeah, k-means learns the centroid. Minimizes distance between each data point and centroid. Not each data point, it minimizes intra-cluster variance. Okay, it minimizes intra-cluster variance while it increases inter-cluster distance. So between two clusters it increases distance. Inside the cluster it reduces variance. So see, this is a very easy question. Assume the use of the gradient distance and a distance metric for value k equals to 3. What is the class label for point this? Okay, so this point is closest to which class? I mean, you compute distance and then see. This is closest to which one? 0.9 very fast, 0.53 close. 8 is, and 6. Anybody can compute and tell me. Let me just let we can like ask GPT and. But anyways, you have to what you have to do is you take this difference. Okay. So k3 means you have to take. You have. Yeah. No, yeah. K3 means you have to take 3 outputs. Okay. K3 means you have to take 3 sets of outputs to determine. Okay, so you have to take basically closest 3 sets. So assume I compute distance between all points. Then what I do, I pick 3 closest one, and out of those 3 closest one, which if A is more or B is more, like if there are 2 A's or 2 B's, I think there are 2 B's. That's why the answer is B. There should be 1 A. Okay, or it can be like 3 B's also. That's why the answer is like the 3 B's can also be the case. Okay, so what you have to do is you have to compute Euclidean distance and take top 3, like closest 3 points, and check what is the class, majority class. So that's how bagging works. Okay, got it? This is a simple technique of bagging only. What is the stopping criteria? Only one class remains in leaf nodes, correct. Maximum density praised, correct. Performance metric threshold is achieved, all of the above. So very simple question. Decision tree, entropy is given, weights are given, left entropy, information gain. There's a simple formula of information gain, some probability into log of something like that. So you can just apply it. And you can see that these are the logarithmic values only. These look like log of 2, log of 3, 4, like that. Okay, log to base e basically. Whatever logs we use in this thing, what we call decision trees, those are basically log to base, natural base. Okay, so yeah, these are logs only, so you can compute and find the answer. 638. What is the Gini impurity of perfectly balanced decision tree with 2 classes? That is 0.5. Perfectly balanced, if the data samples are equal, so that is 0.5. If you can compute it, you can even compute it. Once you study, you will find the formula and you can compute it. I'm just going very fast because I have some other things to discuss as well. So in AdaBoost, the final classifier is, see, this thing won't be there. We perform summation. Okay. So and this is the weight. This is the weight of each classifier in AdaBoost. Like I showed, we perform. We stack model. So they are summation. The output is summed with some weight. So weight is like the first model should be given maximum weight 0.9. Then 0.1 should be distributed among the remaining models. Okay. So you multiply that weight. So this weight is multiplied. So this is the correct answer. This is not the correct answer. We don't sum the weight and this thing because they are not in the same space as well. Like this is a relative value while this is the probability or whatever it is. So that's why this is incorrect. We do not directly sum it. We take weighted sum. So weighted sum is only possible in this case. What is the objective of k-means clustering? K-means clustering tries to minimize sum of square distance within cluster, because you want to increase distance between clusters, you want to decrease distance within cluster. Okay, so instead of having a KNN model like this, it would be preferred if a model is like this, far and okay. So sum of square distance within cluster is increased or decreased, sorry. So yeah, that was week 9 of last year. In fact, I can share the solution. Like what? Why was I discussing everything? The solutions are available here only. Anyways, see, let me show you. Let me show you. See, distance is 0.3475316726. So 26 is lowest, class A. Then 27 class B, and then 34 class B. Sorry, 31. 31 is the third one, class B. Okay, so see, class B, class B. Two are class B, one is class A. So number is higher for class B. So yeah, that is the correct formulation of this thing. See, this is C. See, I can see. So 0.6 is the weight, and entropy is given. So 0.6 into 0.45, 0.4 into 0.23, you sum this thing and then you subtract 1 minus, this is the output. This is given here as it is. This answer is, it is given here. Minimizes sum of square distance and sign cluster centroid. I think discussed all of it. Any doubts in assignment 9? Week 9 assignment. Yeah, Praveen. You don't have to raise hand, just unmute yourself and speak. In this week's assignment 9, right? In this week, in this year, sorry, in this year. On last 25. No, 24. Which question do you have doubt? New one. Okay, let me go. Let me go to the assignment. No problem. I can discuss the basic. Which question was you asking? Which question? Question. Yeah. Uh, the answer. I will give you a hint. Okay, it's not this answer. It's not this answer. This. Even if you give it to ChatGPT, it will give you the answer. I mean, it's very basic thing. You. Okay. So even like I can show you that. Let me check. Anyways, I know the answer, but let me check and confirm. What's the answer? Okay, so my ChatGPT somehow got hacked. I don't know. Let me copy paste and check. There's some network issue, I don't know. Why is my chat GPT behaving like this? Anyways, the next this week's assignment questions seem completely not non-numerical and easy compared to last year. Okay, so anyways, that would be all for the assignments. So any other doubts you want to discuss? Any doubt about your research or whatever you are facing? Okay, so anyways, I will show you something. Let me open Twitter. Let me open Twitter and show you. So I think Sharon is here or not? Sharon left. So my LinkedIn looks something like this. It has a lot of stuff revolving around machine learning and NLP. Sorry, this is Twitter. My side LinkedIn. Okay, so let me show you. What was that? This was something related to Sharon's interests. But anyways, you should see this. So Nvidia and Nvidia, you know what is Nvidia? You all guys know, right? Nvidia is the computing manufacturer of the world. They manufacture GPUs. They have somehow partnered with PyTorch not to support any other type of GPUs. The kind of monopoly Nvidia holds in the market is like incomprehensible. Even Coke and Pepsi don't hold that type of monopoly. Okay. So they introduced Newton. Newton is their sort of open source physics engine that is developed by Nvidia, partnered with Google DeepMind and Disney Research. So Disney also does research apart from making Marvel movies, if you know. So Disney Research, so whatever AI, VFX you see in movies, that is developed after research only, and that is what Disney Research does. So they partnered and created this AI, this robot. Nvidia made hardware, DeepMind made software. Disney provided their real-world simulation data, which they basically use to mimic or to create CGIs. So there's a robot movie, I don't know what, I forgot the name. It goes to Mars and etc. Something like that. So that basically helps a lot. That basically helps a lot. That Nvidia research of creating CGI, how the body works. So they have created this robot type of thing, and in later works, actually they have made this open source as well. So there's a code, the training model, etc. Everything. So you can create your own robots if you want. Now I tweak it to do things, a lot of things. So this is how it behaved in the real conference. Is my screen visible? Is it visible, right? Okay. So see how is this walking, scanning the whole room, and the antennas around the ears behave like ears, actually, like ears of rabbit or cat, I would say. So it's interacting with this person. The person is the CEO of Nvidia. And when someone claps from the audience or says something, it turns towards audience like this. See, it just, I don't know like what usage it will have. It can have usage in I would say like Boston Dynamics has also been doing some things. Boston Dynamics, how many of you know? So yeah, Boston Dynamics is a company that does research on robotics and all. So they have made some similar stuff that basically helps you, what should I say, create robots. But that is not public, first of all. So real robots, I don't think so. They go to into defense and all, but I think they can go, and this type of technology can be used in open source research to scan data. So as assume I have to create some other like my own model to uh, collect some data in real world. I cannot afford an autonomous vehicle, so I can just create this type of robot, and it can just walk and collect data around the campus of IIT, and that data can be used. I don't know like what are the future like. Can anyone tell me what other prospects are possible for this type of robot? Raveen, what can be the possible uses of this type of robot or Android, or so I would not say Android, I would Droid. Yeah, but like right now there are robots which can roll their wheels and do the same thing. But the problem with them is the wheels can get stuck, and this walking thing can help a lot. This small architecture of walking and can help a lot. And the degree of freedom of this robot is quite high. Like it can just rotate its neck and watch anything inside. It can act like a periscope type of. So I don't know what are the possible uses, but anyways, this was one product which fascinated me, and I'm like looking forward to the future uses of this product. Apart from that, there was some other product by GPT or I don't know Mistral. So if you follow large language models, you will see Mistral is a company, Mistral AI. Okay, so that has released Mistral Small 3.1 24 billion instruct. So 24 billion parameters. If you don't know, Mistral models have generally very high parameters. So OpenAI O3 Mini, it has around 700 billion parameters. This one Sonnet has a lot of parameters. Anthropic 32 billion is Quen. Then like these are very big parameter numbers, and you see Mistral Small is 24 billion only. These are 27 billion. Haiku 32 billion. GPT-4 mini is very high. So see what is the progress, what is the performance? Very high, and latency is very low. It performs your operations comparatively faster. Okay, so this is another part, another research which happened in last week. Okay, so that is also worth watching, and let me show you something else. Yeah, so people generally worry about how to extract data from documents. Like it's a very difficult task to extract data from documents. Okay, because there is no model which knows what is where's the table, where's what. It cannot annotate and you cannot pass it to LLM. So they have created this paper has created a data set for document layout analysis. So you can basically see these are all are different types of complex page layouts. This is sort of you say a prospectus which you get when you visit a company. Okay, that this is like a user manual. These are some manuals. So they have different layouts. So they have annotated it, and that can be used to train a model that can fetch features from these documents and these LLMs can be used to train these things. Okay, so see this is how it scans text, heading, text, image. The shades are different. The shades tell what type of thing it is. Heading, this thing tells it's a logo. Okay, so this is how it works. This is a very nice dataset which can be used by experts. So what I thought was, since I like our sessions end quite soon, so I will explain what is happening in the field of AI in recent times, so that way you can keep yourself updated. Okay. I think yeah, that would be all. So, anything you guys want to discuss? Anything relevant to your research, or any doubts? Any doubts in current machine learning scenario, NLP scenario, or even CV scenario? I know a bit of computer vision as well. So, yeah, this is a very different, like very much. What do you say? The grok thing. Okay, so I'm telling you this grok thing. Hello, am I audible? Hello. Okay, so whenever you see a tweet, now Grok has made it easy to use all this thing. The whatever threads are there. Sometimes tweets are very long, so you click on Grok, and it will basically summarize this whole thing here in smaller versions. So it has given me this tweet has follow-up threads. There are 4 web pages allotted to it. You can just click here and watch. So now I don't have to read the whole tweet. So if I ask it to explain DAPO system, so there's a DAPO, there is the paper for DAPO. If I click explain DAPO system, it will explain me DAPO system. It will go to the code and give me the output. So Grok is the model proposed by Twitter, the this X, okay, that does these operations. Okay, so it's gonna take time, anyways. So this is how you can basically utilize these LLMs, which are free for you. They help a lot. So yeah, I think that would be the end of session for today. And if I have any doubts, just let me know. Let's wait for 5 more minutes and let's see if like if you want to discuss something, or shall we end the session? Okay, so I think that let's end this session. Let's meet next week. This week actually, Friday on Friday, and let's discuss week 9 of this year and week 10 of last year. Yeah, that would be all. Thanks a lot, guys. Bye bye. Take care. Have a great night. Good night. Bye bye.